Algebra in P3 can look intimidating, but once you see the patterns, it all comes together. If you've ever been stuck on long division, binomial expansion, or tricky modulus graph, this walkthrough is for you. Today we're breaking down real exam questions from 9709 Algebra P3 step by step, no shortcuts, no confusion. By the end of this video, these questions won't just make sense. You'll be ready to tackle them with confidence in exam. This is Global Math Mentor. Let's get started. So before we dive into solving the actual exam questions, let's take a quick glance at algebra section from the Pure Mathematics 3 syllabus. These are the key areas that Cambridge expects you to master. So first, we need to understand and work with absolute values, things like sketching graphs of linear absolute functions, solving equations and inequalities involving modulus. And next is polynomial long division. We should be able to divide polynomials up to degree 4 by linear or quadratic expressions. Then comes the remainder and factor theorems, and later you need to be able to decompose rational functions into partial fractions in the cases which are given. So finally, there is binomial series expansion and its validity, like the convergence criteria. So I'll be solving questions and I'll hit each and every bullet which is given in the syllabus document. Let's get started. This first one is from Summer 23 question paper 3-1 and question 1 on that exam. First part says sketch the graph of y equals to 2x plus 3, which is a linear modulus function. So how do you sketch it? First, try to get the vertex of the graph. Vertex mean like the highest or the lowest point. In this case, it's the lowest point. So 2x plus 3, you can use the idea of transformation as well. When there's a negative sign outside, then your graph looks like this. And when it's just a positive sign, your graph will look like this. You'll see why. So you put this expression inside the modulus equal to 0, and this will give you x equals to a negative 3 over 2, or you can say a negative 1.5. Okay, that's your vertex. If you want to find the y-intercept, it's just a 1-mark question, but let's make it as nice as possible. So y-intercept, put x equals to 0, then your y value will be the absolute value of 3, which is a 3. So 0, 3 is the vertex, the y-intercept, and minus 1.5 and 0 is your vertex. These are enough to sketch your linear modulus function. So we've got like a minus 1.5 and 0 over here, and a 0 and a 3. Remember, it's just a sketch. So, but you can use a scale while you sketch it in the exam, because otherwise it will not look very nice. So y and x. And what does these arrows in the end mean? It means that since there is no domain given for this function, so I know that it will be limitless. Sometimes, I mean, if you get a restricted domain, for example, x is, let's say, within 1 and negative 4 or something, then you end your graph on these endpoints, right? But since there was no domain given, so my graph shows the open arrows. This is the vertex, this is the y-intercept. All right, so this is part B of the same question. Solve the inequality 3x plus 8 greater than the absolute value of 2x plus 3. Okay, so there are different ways in which I can solve this. The classical or the traditional way of solving this is, let me just show you. So let's call this method 1, and then I'll stay tuned. I'll show you another way of solving this using your sketch, right? So this is the non-sketch way. So whenever you have an inequality like this, two main situations can exist. Like if both sides are linear absolute or modulus, or like in this case, only one side is absolute, which is the right side, and the left side is just a linear function. So you will start your solution by squaring both sides, right? So square both sides, and this, when you square, the modulus is just an equivalent, so it goes away. So let's expand this. 9x squared, 24 double is a 48x plus 64 greater than this is a 4x squared plus 6 to 12x plus 9. So if I simplify this, subtract 4 and then subtract 12, so that will be 36x and subtract a 9, and that's going to be a 55, and this is greater than 0. So this now becomes exactly the quadratic inequality which you learned in Pure Mathematics 1. Okay, so let's try to factor it out. What's 55 times 5? I mean, here you can go with the calculator or whatever way suits you, but still, you need to show some sort of method mark. So what's 55 times a 5? That's a 275. Well, that's a huge number, so I quickly need to check. So you'll see that for 3 marks, it doesn't look like a very nice way of solving this, but still, it works most of the time. So 5 times 25, 555, and this is a 5, 11, and 11, 1. So you can see that 25 plus 11 is a 36. So I can just factor it out like 5x squared plus 25x plus 11x. Those who are really good with the algebra or factoring a quadratic. But otherwise, like you might be thinking, what if I can't think about such a method? You can apply the quadratic formula and get your roots. And then, because obviously, you need the roots to solve the quadratic inequality. You need to sketch it. You'll see what I'm talking about. So if you have any confusions solving quadratic inequality, I'll share a link in the description where there's a whole video I solved quadratic inequalities in detail, right? So 5x is going to be x plus 5 and plus 11, and this is the x plus a 5 greater than 0. So this will be x plus 5 and 5x plus 11, which is greater than 0. So my critical values are, there is a negative 5 and negative 11 over 5. So negative 11 over 5 will be here somewhere, since the negative 2 is it's a bigger value as compared to negative 5. So my solution set is this thing, like this region and this region. Okay? So this is the x-axis. So now this is the part where you need to focus. There are two values, two solution set, but mark my words, one of them is the correct answer. Reason being, you can even write a tiny notes. You need to verify each solution when one side is modulus. Okay? So keep that in mind. So I'm going to test any value. So let's verify the x less than minus 5. So can you think of any value which is below minus 5? Let's say minus 6. Okay, I'm going to test my actual modulus, or like the inequality which is given. So if I put a 3 times a negative 6 and plus 8, this will become 2 times a negative 6 and plus 3 modulus, which is negative 18 and plus 8. And this will be a negative 12 plus 3. So minus 10, well, there you go. That's the problem. So negative 9 modulus is a 9. So a negative 10 can't be bigger than a positive 9. So this is a rejected solution, this one, x below 5. So now I know that this is the only correct answer, but still, since we are discussing these problems, give me any value which is above 11 over 5. 11 over 5 is like 2 point something. So I'm going to take, let's say, a positive value 0. So if I take 0, the left-hand side of this initial inequality becomes 8 and greater than the absolute value of 3. So 8 is greater than 3. So this is valid solution. So you can say this only. Okay, so stay tuned. I'll solve this same question, because since it's just a 3-mark problem, what if I can use the sketch in part A to solve this inequality? So stay tuned. That's another clever way of solving these inequalities. We now look at another method of solving the same part that I was solving earlier. This is method 2, the sketch method or the graphical method. And have you noticed I have taken the sketch which I made in part A for the same absolute valued linear function, this one. Understand absolute valued function in better way. Why do you have two branches? Since the absolute value has a positive and a negative both existing together. So you can say that this branch over here has the equation of 2x plus 3, and this branch over here has the equation minus 2x minus 3. Now bring the linear graph, which is y equals to 3x plus 8. If I can sketch this on the same grid, you'll see how I can solve my inequality pretty quickly. So for y-intercept, I know that if you put x equals to 0, y is 8, and if you put y equals to 0, x will be a negative 8 over 3. So negative 8 over 3 is a negative 2 point something. I just need to sketch my line, and it has a gradient of 3. So 3 is a more sharper line because its gradient is 3, and this graph has a gradient of 2. So my graph will look something like this, a more elevated one. Let's bring up the y-axis like this, and this is a 0 and 8. Okay? So now if I can get this part, because this is the part where the line and the modulus graph intersect. So I'm going to solve minus 2x minus 3 with my linear function 3x plus 8. And this will be negative 11 equals to 5x. And hence I get my critical value, which is minus 11 over 5. Let me just mark it over here, minus 11 over 5. Now listen carefully. Where is your line above the absolute function? Okay, that's the question. What part of your graph? So look at this line. Okay, this is a line, and look at the V graph. So where do you think so is your line above the graph? Obviously, to the right side of minus 11 over 5. Have you noticed? Pause the video. If there's any confusion, you can rewind and check again. So according to this diagram, my solution set is x greater than minus 11 over 5. And you can write only. So you have justified using your sketch. Okay, now what's the conclusion? If you're good to go with first method, fine. You can always apply that. But if you are looking for more ways to solve it quickly, keeping the marks in mind, since it's just a 3-mark question, so you can explore this method as well. All right? So this one is from summer 20, question paper 3-1 and question 2. Expand 2 minus 3x to the power of minus 2 in ascending powers of x up to and including the term in x squared, simplifying the coefficients. So this is part of the binomial series expansion question. So there are some key conditions when you go for the binomial series expansion. So you must know that the first term must be 1. This is the form which we use in binomial series expansion. So it goes like 1 plus nx plus n minus 1 divide 2 factorial x squared plus dot dot dot. So this formula is given in the official MF19 formula booklet as well. So what are the main features of this expansion? Number 1, a must be 1, and n is a rational number. So unlike the binomial theorem where it was a positive integer only, this time you can have a rational value. Okay, so let's apply this expansion. First, I need to make this 2 1. Okay, so if my expansion looks like 2 minus 3x to the power of negative 2, I need to factor out the 2, and this will be 1 minus 3 over 2x and whole power negative 2. What I have observed, most of the work is messed up in these early steps. So if you have not practiced much, start practicing. This is how you should start your expansion in the case when the first term is not 1. So now my expansion will look like 1 over 4 and 1 minus 3 over 2x to the power of minus 2, which is perfect to go. Okay, so I can write 1 over 4. Now I do my expansion, and this will be 1 plus nx. So x is a minus 3 over 2x plus n minus 1. Pause the video if you have forgotten the formula, and you can go to check MF19, and you will find this formula for binomial series expansion over there. N minus 1 over 2 factorial, and this will be x squared and plus dot dot dot. I don't need to go any further since they are saying up to and including the term in x squared. Sometimes they might ask you to go all the way up till x cubed, but not this time, because this will be 1 over 4. 1. I can do some simplification over here. So this cancels this. This will be a 3x. Okay, so this is a plus 3x. Okay, if I simplify this, this will be minus 2 minus 3 times a 9 over 4x squared and 1 over 2. You can use calculator and find these values. So this will be plus 27 divide 4 plus 27 divide 4 and x squared and dot dot dot. So now I just expand my bracket and that will be my answer. 1 over 4 plus a 3 over 4x plus 27 over 16x squared. This is the expansion. Part B, state the set of values of x for which the expansion is valid. If you check the binomial series expansion formula, I'm not going to write the whole formula. 1 plus x to the power of n. If this is the form, then this expansion will only be valid, or you can say converges, if x mod is less than 1. So you need to put this value. What was the expansion I was using earlier? It was 2 minus 3x to the power of minus 2 in part A. 2 to the power of minus 2 and 1 minus 3 over 2, x to the power of minus 2. So you can put this value, 3 over 2x, even if you put the negative or the positive sign, still, since it's the modulus, it will be positive, less than 1. So what more can you do about this? 3 over 2 is just a positive number, so you can pull it out, and x mod is less than 1. And finally, you can write it. Oh, I'm just x mod less than a 2/3. So this is a correct way of giving this answer. Or maybe if you want to go one step forward, you can also write this thing as x is within a 2/3 or a negative 2/3. So this is also a valid answer. So express 6x squared minus 2x plus 2 over x minus 1 times 2x plus 1 in partial fractions. This one is from summer 24, question paper 3, question 5 on that exam. Whenever you start making partial fractions, watch out, stop and think, is this some improper fraction? Like in this case, you can check this is an improper fraction. So for this, you need to first do long division. I mean, you can go with a coefficient comparison, but this is how I teach this topic. So algebraic long division, in any case, is part of the syllabus. 2x squared. If I simplify the denominator, it's going to be plus x minus 2x, so minus x and minus 1. Okay. So I divide it, which will be 3 times, and this will become 6x squared minus 3x and minus 3. Okay. Now you subtract the lower expression. If you have any difficulties related to long division, I'll share a link in the description. There's a video where I explained in detail how to do polynomial long division. X plus 5. So you used to write the mixed number as 3 whole, this remainder over divisor. But we can write it like 3 plus x plus 5 over. Again, instead of writing this, you can write its factored form, x minus 1 and 2x plus 1. Let's call this equation E. Okay. So any long division can be, the answer can be given as quotient plus remainder over divisor. Okay. So now from E, I pick this expression x plus 5 over x minus 1 times 2x plus 1. And I do my usual simple normal partial fraction procedure where it's a proper fraction and both factors in the denominator are linear. So x minus 1 and plus b over 2x plus 1. So let's multiply this equation with x minus 1 and 2x plus 1 to make it simple. And now I form an identity equation. X plus 5 equals to a times 2x plus 1 and plus b times x minus 1. Okay. So in this identity equation, you can assign values. I can put a 3 bar over here This means that this equation is true for all possible values, infinitely many values of x. Okay? So let's choose x equals to a negative 1/2. Why? Because this will make this thing 0, and I can get negative 1/2, 1/2 plus 5 equals to b times negative 1/2 and minus 1. So this implies that it's going to be 9/2 equals to b times a negative 3/2. So 2 cancels 2. So b will end up a negative 3. Okay. So now I can assign x equals to 1 because this will eliminate b and I will get a. 1 plus 5 equals to a times 2 plus 1. This implies that 6 is a 3a and a will be a 2. Okay. Once we're done with this, I can sub back the values in these a's and b's. This will become 2 over x minus 1 plus, sorry, that's a minus. So I can put a minus 3 over 2x plus 1. And if you sub this back in e, your answer, the final answer will look like this. So these are my partial fractions. There are other types worth noting. Sometimes there's a repeated factor in the denominator. Sometimes there's a pure quadratic factor in the denominator, which are interchangeable. I mean, you can solve them same way, or there's a different way for both as well. And this is the last type, which is the improper fraction type. And in partial fractions, you won't be given any fraction when the numerator exceeds that of the denominator. I mean, you can get that question in long division, but not in partial fractions. So go over the syllabus list again and you'll find out what I'm trying to tell you. Another question on partial fractions. This one is from Winter 24, question paper 3 and question 8 on that exam. So it's a tricky question. Initially, it looks like this is an improper fraction since there's a squared term on the numerator and the denominator is also a quadratic. But look at this one. We need to express this as partial fractions, but a is a positive constant. So even if you square a constant, it will still be a constant. So this is the normal simple type of partial fraction with the linear factors in the denominator plus x, so I can write it. You can suppose any alphabets A, B, P, Q, S, T, but usually we go with the A's and B's. A minus 2x plus capital B over 3a plus x. Okay. Now I simplify this identity equation by multiplying both sides with a minus 2x times 3a plus x. And this implies that my identity equation will look like 7a squared. Put the 3 bar because you're going to assign values. So a times 3a plus x plus b times a minus a 2x. Okay. Now, what will make a 0? If I take x equals to a negative 3a, this will make this thing 0, and I can get 7a squared equals to b times a minus 2 times a negative 3. So that's a plus 6a. That's going to be a 7a. So my final answer for B will be a 7 cancels 7. So a squared divide a. It's a constant. Remember, it's not a variable. So B will be just the alphabet a. Okay, when I assign x equals to, let's say, a divide 2, okay, this will make this thing 0. So, I mean, if you get confused, how do we decide which values to pick? So what you can do, you can put a minus 2x equals to 0 and try to solve this linear equation to get that specific root or solution. Whatever is the solution of this expression will make it 0. I hope you get this idea. Okay. And 7a squared, this will become a times 3a plus a divide 2. So this implies that 7a squared will now look like a times 6 plus 1, 7a divide 2. 7 cancels 7, a cancels a. So a is going to be 2a, where a is some constant. So my final partial fractions will now look like 2a over a minus 2x plus a divide 3a plus x. So I'm using a lot, but remember one of the a is the capital one and one is the small one. That's the final answer. This is part B of the same question. Hence, obtain the expansion of fx in ascending powers of x up to and including the term in x squared. So for this one, I'll be needing my answer from part A, which is, so let me bring that, this one, okay? So I'm going to use my partial fractions, but in order to apply the series expansion, there are some things to consider first. So number one, take the first expression. This can be written as 2a over, I need to make the first term 1, so factor out a. This will be 1 minus 2 over ax, okay? Plus a, and now I need to factor a 3a, and this will be 1 plus x divide a 3a. Why are we doing this? Since you know, or if you don't know, better find out, see the lesson like earlier I told you. Binomial series expansion, the first term must be 1. Otherwise, the series doesn't converge. It's not valid. So we can get rid of these constants. Remember, a is just a constant. So my form will look like 2 times 1 minus 2 over a x to the power of negative 1 and plus 1 over 3 and 1 plus x over 3a to the power of negative 1. You should not be going out from these lines when you're solving the actual exam, but I'm sorry about that because I was just solving a video. Okay, so let's call this E. Now I'll take these individual binomials and expand them one by one. 1 over 2ax raised to the power minus 1. I need to go up till the term including in x squared. So this is 1 plus nx plus, this is n minus 1 divide 2 factorial and x squared. So let's simplify this. You can use a different color pen if you want to. This will be 1 plus a 2 over ax. Now think about this one. This is just a 1. Since minus 1 times a minus 2 is a plus 2, 2 divided 2 is a 1. Plus, this will be 4 over a squared x squared, right? Now pick the second one. This is 1 plus x over 3a raised to power negative 1. This will be 1 plus nx plus n minus 1 divide 2 factorial and x squared, right? Now I'm going to simplify this again. 1 minus x over 3a. And now I can get rid of these because it's just, I mean, if it's not 1, the power negative 1, then this won't be. So watch out if other powers are there. So then you need to multiply and get the exact answer. Over 9a squared. Let's put them back in E. So sub in E, right? So my expression will look like 2 times 1 plus 2 over ax plus 4 over a squared x squared and plus a 1/3 1 minus x over 3a plus x squared over 9a squared. I'm running out of space, but I'll try my best to simplify this here. 2 plus 4 over ax plus 8 over a squared x squared plus 1 over 3 minus x over 9a and plus x squared over 27a squared. Okay, so you need to now simplify these. So let's see, 2 plus a 1/3, that's going to be 6 plus 1. A 7 over 3, that's the first term. Okay, what will be a 1 over a? And okay, who cares about the a? I can just do, for the x terms, okay, let me just do some rough work. 4 minus a 1/9. Okay, that's 36 minus a 1. So that's a 35 over 9, a and x. All right. Now last, the squared term. So I've got 8 and plus a 1 over 27. These are huge numbers. I mean, I encourage you to use calculator, but I don't know. I'm just doing some mental math today. Okay, that's 216. 27 times 8 is 216 plus 1. So that's going to be 217. divide 27 and a squared and x squared. So that's my final expansion. All right. This one is from summer 23, question paper 3, and it's the second question on that exam. Find the quotient and remainder when this 2x to the power of 4 minus 27 is divided by this quadratic polynomial. It's a long division question. This is part of algebra, x plus 3. Okay, I need to find the quotient and remainder. So how does the algebraic long division work? I need to find what should I multiply with x squared to make it 2x to the power 4. So this will be 2x squared, 2x4. And now I have plus 2x cubed, which doesn't match with minus 27, so I can just write it to the side, and plus 6x squared. So I need to subtract the lower polynomial from the above. This goes away. This will be negative 2x cubed minus 6x squared and minus 27. Now I do minus 2x. This will become minus 2x cubed and minus 2x squared and minus 6x. The 6x doesn't match this 27, so I'll write it to the side. Okay. So I have some missing terms in the actual polynomial. That's why. So this will become minus 4x squared plus 6x minus 27. So this will become minus 4 because I need a negative 4x squared, and minus 4x and minus 12. Okay. So this becomes cancel 10x and minus 15. Okay. So what's your quotient now? Quotient is that polynomial on the top, which is 2x squared minus 2x minus 4. And remainder is this term at the bottom, 10x minus 15. So these are your answers. Okay, so this one is from winter 23, question paper 3 and question 3 on that exam. The polynomial is given where a, b are constants is denoted by px. So let's denote this by px as given, 2x cubed plus ax squared plus bx and plus 6. When px is divided by x plus 2, the remainder is minus 38. Okay, so this is a remainder theorem concept. So when divided by x plus 2, it means this implies that p of negative 2 is a negative 38, right? So let's get this first and then I'll get into the second condition. So this will be 2 times minus 2 cubed plus a times the negative 2 squared plus b times the negative 2 and plus 6 equals to minus 38. This becomes negative 8, negative 16 plus 4a minus 2b plus 6 equals to minus 38. This becomes 4a minus 2b. So this is a negative 10. So it becomes a positive 10 equals to minus 28. So I can maybe simplify this a little further, like minus 14. So let's call this 1. I divided the whole equation by 2. Okay, so the second condition, this was the first condition. Sometimes they give another condition like one of the factor is given, but this time both of them are just divisors since we are given remainders. So when it is divided by 2x minus 1, the remainder is 19 over 2. So the other condition will be p of a 1/2 will be a 19 over 2. Let's simplify this one. 2 times 1 over 2 cubed plus a times 1 over 2 squared plus b times 1 over 2 and plus 6. And remember, the remainder and factor theorems are only applicable if your divisor is a linear one, okay? Otherwise, you have to go with, sometimes you can go with syntactic division or maybe long division. But long division, I highly recommend as it is given directly into the syllabus. Okay, so 1 over 4 plus a over 4 plus b over 2 and plus 6 equals to 19 over 2. What if I can multiply the whole equation by 4? This will be 1 plus a plus 2b plus 24 plus, it's equal. So 19 double is a 38. This becomes a plus 2b equals to 38 minus 25. A plus 2b will be 13. Let's call this equation 2. So I need to solve these two together. You want to go with substitution or elimination? It's up to you. Okay, let's do elimination. It's been a while, huh? So I'm going to time this with 2. This becomes 4a minus 2b equals to minus 28. And let's bring back this one. And we can add these equations. There we go. 5a equals to, that's a minus 28. This will be minus 15. So a is a negative 3. A is negative 3. And now I can get my b like negative 3 plus 2b equals to 13. 2b is 16. So b is 8. And these are my a's and b's. And this is the last question on this video. This is from summer 20, question paper 3, and question 1 on that exam. So I'm again going to solve a modulus inequality. I solved previously in this video. You can go back and check. That was a bit tricky one since one side was absolute, the other was not. One side was just a linear function and the other was a linear absolute function. This time we have both sides absolute valued, or you can say modulus, right? So how do we start with these inequalities? Square both sides first. And this will be, you need to square this 3 as well. So let's just write it once like this. And 4x squared minus 4x plus 1 greater than, this will be 9 times x squared plus 4x plus 4. Okay. Whatever way you do your expansions, 9x squared, 36x, and 36. And well, I can make this 0 and subtract, add 4x and subtract 1 as well, right? So this will be 5x squared and plus 40x and plus 35 less than 0. Before you solve it, this is just standard algebra. You can divide both sides by 5. So this will become x squared plus 8x plus 7. And that's an easy quadratic inequality to solve. Let's just factorize the quadratic. And some students just write it straight away. They just do it in their head. It's okay. I usually like to show my steps. Okay. And x plus 7 less than 0. And this time, as I'm mentioning a question that I solved earlier, where I verified each solution, but this time I will not, since both sides are modulus. In that question, only one side was modulus. So below x-axis, less than 0 means below x-axis. This is your solution. So my solution set is within -1 and -7. Okay? And that wraps up all the questions for today's session. I hope this walkthrough gave you clarity and confidence for tackling similar exam problems. We've gone through the full set of questions, and I hope you noticed how practice and clear strategies make the toughest algebra manageable. This is Global Math Mentor, over and out.